Hi, Bright Mind students. Welcome back to the Engineer Squad channel. Today, we will learn kinematics, one of the branch of physics. The speed of a particle experiences a constant deceleration from 30 meters per second to 15 meters per second, and traveling a distance of 75 meters. How much further will the particle travel before coming to a stop? To answer this question, we will create an illustration for better understanding. There is a particle, and at point A, it has a speed of VA equals 30 meters per second. This particle moves with deceleration until it reaches point B. At that moment, its speed, or VB, is 15 meters per second. It is known that the distance between A and B is 75 meters. Then, this particle moves until it reaches point C, where it stops, or the VC equals 0. The question is, how long is the distance between point B to point C? What we need to define now is the deceleration of this particle. Deceleration A is the change in velocity divided by time. That is, VB minus VA divided by t. It is given in the problem that VB equals 15 and VA equals 30. As for the value of t, we do not know it and need to define it. To find t, we will use the distance equation. The distance between A and B, or SAB, equals to initial velocity multiplied by t, plus 1/2 times A times t square. The initial velocity here is VA. We substitute SAB as 75 meters. VA with 30, multiplied by t, plus 1/2 times the value of A from here, and times t square. In the last term, t can cancel each other out. Thus, we get 30t plus 1/2 times minus 15 times t. This becomes, or we can write it as, it results in 45 divided by 2 times t. We can calculate it. And we get t is 10 divided by 3 seconds. Before we continue, I would like to remind you to support this channel. Please like this video and subscribe to this channel, so we stay motivated to discuss other science problems. Thank you to those who have supported us. Let's continue with the discussion of this problem. From the value of t that we have obtained, we can calculate the deceleration of this particle. That is, minus 15, divided by 10 over 3. Thus, we can find the value of A is minus 9 over 2. Since the problem mentions constant deceleration, A in segment AB and segment BC is the same. Now, we will calculate the distance traveled from B to C. Using the formula, SBC equals initial velocity multiplied by t plus 1/2 times A times t square. V0 for BC segment is VB, which is 15 meters per second. The t in this segment is still unknown. We denotes it as red t. The value of A is being substituted. Now, we should find out the value of red t. A equals delta V divided by t, minus 9 over 2 equals VC minus VB divided by t. We substitute with a VC and VB. Both minus sign can cancel each other out. Then, we get the t value is 15 times 2 divided by 9. We calculate it. It results in 10 over 3 seconds. This t value is being used in formula of SBC. We get the equation. Then, we calculate. We get 50 meters minus 25 meters. Therefore, the distance of BC is 25 meters. That concludes the discussion of this problem. We have determined the distance traveled until the particle stops at point C. Here are the formulas related to uniformly accelerated motion. We have already used these formulas. Hopefully, with this practice problem, we will understand and enjoy physics more. Don't forget to subscribe to the Engineer Squad channel. And see you in the next problem discussion.